Hello everyone. Today I am going to explain the topic Newton interpolation forward and the backward difference. Let's see what is forward difference. A comprehensive reference for the interpolating equally spaced data using the Newton forward and the backward means if the difference between the data is same, then we apply the method Newton forward and the Newton backward difference. Let's see Newton forward. It is used when interpolating near the beginning of the table work on the equally space. Means if we want to find the value in the starting of the data, then we use this Newton forward. And if we want to find the value at the backward point, then we use the Newton backward. Newton backward used when the interpolating near the end of the table work on the equal space means if near the end if we want to find the value at the near of the end then we use this Newton backward. What is the formula of this Newton forward? Delta y0 is equal to y1 minus y0 and delta square y0 is equal to delta y1 minus delta y0 means if the value of data delta 1 means y1 minus y2 and again if we want to delta square y0 then delta y1 minus delta 2 means this is the basic formula to design the table. And if we see this backward difference, then this is not delta, this is nebula yn is equal to yn minus 1 and delta and nebula square yn is equal to nebula yn minus nebula yn minus 1 means we will subtract the least value with the uh, more value, and this is the table of the backward difference. The formula of the Newton forward interpolation is f of x is equal to y0 plus p delta y0 plus p minus 1 into p divided by 2 factorial into the delta square y0 plus p minus 1 p minus 2 divided by 3 factorial delta cube by 0 plus dot 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 where the value of p is equal to x minus x0 divided by h. H means what is the difference between the two consecutive data. And similarly, Newton backward formula is f of x equal to yn plus s nebula yn plus s plus 1 and this is difference. I mean here we will subtract and here we will add and divided by 2 factorial and similarly formula and the value of s is equal to x minus xn upon h. Okay, let's see the algorithm one by one. First of all, see the algorithm of the forward difference. And first step, read the and data points. So first of all, we will read the data points x0 y0, x1 y0, x2 y0, and dot 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 goes to infinite. Where the xv to find, and here we have to find the value of xv in second step. In second step, compute step means the value of h. And how we calculate means if we difference the x1 minus x0, then we will get the value of h. And here in fourth step, third step, build forward difference table. This is the logic behind finding the a table of the forward difference. Then ahead we will find the value of p. Here this is the formula for finding the p is equal to xp minus x0 divided by h. Then in the fifth step we will find the sum of the all the term and print the f of xp. This is our final interpolated value. Okay, and similarly, let's see the elbow of the Newton backward. In first step, read the value of n data points and xp to find, and ahead we will find the value of h. Here we will minus this larger value minus smaller value xn minus xn minus 1 last step, and ahead this is the logic behind the table and how will how we build the table. And this set parameter s is equal to, this is the formula for s. This will be calculated and we will apply this formula to find the sum of the all the terms, and here we will print the output. Okay, now see next page. Now see the code. Let's see the code. For code for the forward difference. Head include head. This is the header file, and then we start the program from the int main. Int I is equal to int n. This is the n, matlab how many terms. I is the variable, and the float by x0, x20, and this is the value in xp, xp, and these all can be defined. Enter the value of data point. We will take the data point in the n, and then we will enter the value here in this loop, and we will take the inputs from the user of x zeros and y zeros, and ahead print the value of xp. In this user will give the value of xp, we will store in the xp, then consult the forward difference table, and we will consult the, this is the logic behind drawing the forward difference table. First of all, we will take z is equal to 1 and check this condition. This, if this condition is right, then we go ahead and check this, and if I is equal to 0, then we will take this value. Then in case the value of I by 1, I is equal to 1, then we will check this. If this satisfied, then this again, matlab, then this whole condition will satisfied, then we find the value of this. Then next go, and here we calculate the value of h, x1 minus x0. This will give the value of h, and next we will find the value of p. Calculate p. This is the formula to calculate the value of p. And next sum value, and next and term is equal to 1 ले लेते हैं अपन. उसके बाद and if, and this is the this in this step we will apply the Newton forward formula. This is the logic behind the Newton forward difference, and the after getting these we will print the sum. Here we will print the sum, and this is our answer, and return 0, and program terminate, and and this code end here. Now let's see the code of backward difference. First of all, we will start from the header file, include studio.h, then int main. Then in when we will take the value of these variables and print, enter the number of data point. Here we will take the value of the data point from the users in the, and we store this in the n. And now we will try to gain the value of the x and y from the user. Here this is a for loop, and this will take all the value from the users and store in the xi and the yi and y0. Okay, and ahead enter the value of, here we will take the value of xv from the user, and ahead, and this is the code for the construct backward difference table. In this is the nested loop. First of all, j is equal to 1, and this will loop enter into this loop from I is equal to n minus 1, and if this satisfied, then this whole value means this whole table will be printed from this logic. And ahead we will calculate the value of h, means the difference between the tables, x1 minus x0. This is the formula for the h, and here we will calculate the value of s. This is the formula for calculating the value of x. And ahead here in this we apply the Newton backward formula. This is the logic behind the formula, and this will give the value of sum, and sum is our answer. So, and at the last we will print the value of sum and return 0, and that's all code of this backward. And now let's see the numerical of this backward and forward. And as we see that the difference between the data points are not equal. So in this the backward and forward difference will not be applied, because it is applicable only when the difference between the data tables are equal. Like 5 minus 7 is equal to 2, and 11 minus 3 is equal to 4, means the difference between the consecutive data variables are not same. So this way method will not applicable. Thank you.